Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 6.1, Solving Systems of Equations by Graphing. Excuse me. I'm getting a little bit of a hiccup attack here. Alright, so first things first, what is a system of equations? A system of equations, so a system of equations is a set of related equations, and that's it. It's just a set of related equations. Sometimes we like using linear equations because linear is pretty nice to work with. Linear usually only gives you one real result most of the time. But there are some exceptions to that. So a system of equations is a set of related equations. So like a bunch of lines on the same set of axes would be considered a system of equations because they're all equations that are related in some way. So a system of equations has a solution. So let's write down what a solution for a system of equations would be. A solution for a system of equations is an ordered set that is a solution that works for all of the equations in the system. A solution for a system of equation is an ordered set that is a solution that works for all of the equations in the system. Meaning that if it doesn't work for one, then it's not a solution for the system of equations. It might work for 5 out of the 6, but that sixth one says, nope, doesn't work for me. That means it doesn't work for everybody. It's kind of like coordinating time when people can get together and work on something. And somebody will say, how about Thursday at 10 p.m.? And somebody will be like, yeah, but I have to work on Friday. And they're like, okay, so that's too late for you. What about a Friday at 8 p.m.? And one person says, well, I have a soccer game at 8 p.m. on Fridays. And like, okay, that won't work for you. What about 10 p.m. on Fridays? Another person says, hey, look, I have to work on Saturday morning from like 4 to 6. There's no way I can do it there. I'm like, okay, well, what about Saturday at 7? And everybody's like, well, Saturday at 7, well, we can skip Walking Dead. Yeah, we could do that. We could do that. So that would be the solving the system of equations, would be finding the time that everybody can get together to work on a project. And trust me, when you get to college and work on projects together, oh my God, does that become a problem. Because everybody has really wonky and strange schedules. Really wonky and strange schedules. All right, now let's get to the meat and butter of this one. For this one, the first method for solving a system of equations that we're going to learn is the graphing method. So this is the graphing method. The graphing method for solving a system of linear equations. Now, we know that not every equation is linear, but that's okay. for now, we're just going to go with the models that every equation that we work with for a while is going to be linear. We're going to get into parabolas and some other nonlinear equations later, but for now, we're just going to go with linear types. And not only are we going with linear types, we're going with linear types in 2 dimensions, x and y. And not only are we doing linear types in 2 dimensions, but we're also doing them so that that they're in the same plane. And we're going to be using the graphing method. Now, the graphing method is my least favorite method. One, because it involves graphing. And you guys know how awesome I am at graphing. Oh god, I'm horrible at graphing. But the other part of it, the part that's really awesome about it, is how inaccurate the graphing method is. Unless you end up on like a pair of points that works perfectly, that there's like no fractions, no decimals, then you're not really sure, and you're kind of estimating what the value is. And that's kind of bad. That's kind of like really bad. That's awful when you're trying to get accurate to the exact nth thing. It's useful for some real life situations where you're like, well, I have to sell exactly 50 DVD players to make a profit or something. Then that part's fine, but a lot of the times we like knowing an exact value for a system of equations. This is actually how I got to be rent-free for a few months when I was in college. Was I used a system of equations and the techniques that I learned from my math courses to help a businessman make more money. And by applying this to his business, I was able to increase his profits by so much that, because he was also my landlord, because I lived above him, above his store, he said that we could rent free there for as long as we wanted to. So for about 6 months, we had free rent because of this kind of a stuff. Because I knew how to work with systems of equations. A little bit more complicated than what we're going to go over, but it's useful stuff. This stuff has literally, it changed my life. It gave me free rent for half a year. I mean, how awesome is that? I would say it's pretty awesome. All right, so here's the method for graphing, or for solving a system of equations by graphing. And we're going to go back to the old t-type. Here we go. And what we're going to do is we're going to start by being given 2 equations. So we are given, let's see some easy ones. X plus 2y is equal to 6. Come on, Ben. There we go. And we're also given another equation, x minus y is equal to 3. So we're starting off with what's given to us. And our objective is to determine where they intersect. Determine the intersection of the 2 lines. Now, we already know that there are some cases where things don't intersect at all, so that means that there are some cases where you're not going to have a solution. There are some cases where the line is the exact same thing, so that would be an infinite number of solutions. But the ones that are actually interesting and useful are the ones where you have exactly one solution. So those are 3 possible outcomes. You can have either no solution, infinite solutions, or one solution. So note, we can have no solution, infinite solutions, or exactly one solution. Those are the only possible things that can happen. Kind of like in a game of chess. You either win, you lose, or you have a draw. And that's pretty much everything that you can have. All the rules for chess and tournament play mean that you either have a win, a loss, or a draw. And there's no ambiguity. There's no, oh, we'll just remake the game. It's win, loss, or draw. If a person makes an illegal move, they automatically lose, which is how a lot of people lose at speed chess. They'll think they're not in check, and then they'll make a move that doesn't alleviate check, and then suddenly the other guy says, hey, I won. You made an illegal move. All right, so the next step is after we're given these, and we know that we can have no solution, infinite solutions, or exactly one solution, we have to graph them. So next step, graph it. I'm going to use the old cover-up method, the old Nixon method. All right, so for the first one, I have 2y is equal to 6, so y would be equal to 3. I'm going to make this guy blue, and I'm going to make the other guy red so that I can tell the difference. Okay, so it looks like I'm at 3y. All right, so I go up to 3 on the y-axis and make a dot. Remember, this is the cover-up method. And then I cover up the other guy, and I have x is equal to 6. So I would go to 6 on the x-axis, 1, 2, 3, 4, 5, 6, and make another dot. And those are my 2 points for that line. Oh, oops, that was supposed to be blue. My bad. Okay, so I'm going to use, once again, a straight edge to assist me in attempting to draw these straight lines. Because, yeah, I can't draw straight lines. So there's my first one. And then for the red one, sorry, I'm trying to overcome a cold at the moment. Or maybe a flu. Yep, flew right into that pun. Okay. Hey, I heard a great joke the other day. How do you know Mr. O'Neill was telling a bad joke? His mouth is open. All right, here we go. On the red one, we have, for our cover-up method, that x is equal to 3. So I go to 3 on the x-axis here. 1, 2, 3, and make a dot. And then I get y is equal to negative 3. So I go to negative 3 on my y-axis. 1, 2, 3, make a dot. And then we graph. Okay, let's see if we can graph this and make it look somewhat pretty. Remember, we've got to go through both dots. Not to be confused with Yakko and Wacko. Alright, and it looks like we intersect at a really nice point. Right here. I'll do that in purple. Because, you know, blue plus red, purple. And that point is at, let's see, count the x's. 1, 2, 3, 4 for the x. So 4, comma, count the y's, go up 1, 1. So it looks like the solution to this system of equations would be at 4, comma 1. So on the next portion, we would say, it says determine the intersection of the two lines. After we've determined it, which we have at 4, 1, excuse me. After we've determined it, we need to test it. So after finding the intersection, plug it in to all equations. So I should erase that. To all equations in the system to determine if it works. So we need to make sure that this intersection actually works. Right now we're estimating, we're guessing. We think it's at 4, 1, but we don't know for sure, and we won't know for sure until we try it out. So let's try it out. We plug it into each equation. So for blue, I have an x of 4, and then a y of 1, and we have to see if that's equal to 6. All right, so for blue, 4 plus 2 is equal to 6. Okay, so it works out for blue. And then for red, we have an x of 4 and a y of 1, and that has to be equal to 3. We get 4 minus 1, which is 3, so that works out. Okay, so it worked for both equations. Again, I apologize for all this wonderful coughing. Maybe I should put an E at the end of it and have some cough E. Okay, that was a bad joke too. Alright. Please don't shoot me. Please don't turn off the video. I know that it's bad, but you can suffer through it with me, right? Right? Okay. Anyway, we determined that 4, 1 was our solution. We double-checked it by plugging it into the equation. We're done. And that's basically what the graphing method is all about. To use the graphing method, it's 3 simple steps. Step 1, graph the equations. Oops. Graph the equations. Step 2, determine their intersection. Their intersection. And then we have step 3, the final step, the most important step, plug and chug to check. Plug and chug to check. And really that's all there is to this particular section. We have a system of equations, which is something new. It's a bunch of equations that are related to each other, usually on the same axes. We have our method of solving the system of equations, which is looking for where these things intersect. And the way we do that is first we graph them, then we look at the graph and say, look, there's the intersection. And then we plug it in to double check, and then we're done. I know it seems like a lot, but it isn't. Once you get used to it, it becomes pretty simple. But it does require all of Chapter 5, because all of Chapter 5 was all about graphing lines. And if you can't graph lines, then you can't do Step 1. So yeah, you need to learn how to graph. Graphing is important. It's the foundation of all upper-level mathematics. It really is when you think about it. Alright, and because you need a lot of practice on it, I'm of course going to give you a lot of practice on it. Yay, practice time! Alright, practice. Practice, which should be practical. I know, bad pun. Mr. Neal, quit doing puns. Fine. Page 400 for section 6.1. And we're looking at numbers 1 through 25 odd. All right, grab some graph paper because you'll need it. Good luck and have fun.